Good morning, respected jury members. First of all, let me thank you that we got an opportunity to present our case in terms of quality, role in sustainability towards the Destination Zero goals. It is of immense pleasure to present our case from Cummins India Limited on the engine test cycle optimization that we have worked through in terms of our quality team's efforts towards meeting as well as the sustainability goals. This is the flow of the presentation where we will give you an overview in terms of what is the project background all about, and then what are the steps that we have taken, what are the tools and the approaches that has been done, and then finally what the results have really come out of the project. As a part of our brand promise in terms of powering our customers through innovation and dependability, we are always committed to innovating for our customers to power their success. This is in alignment with our vision along with our Destination Zero goals, which happens to be our corporate strategy. With that in mind, I'll just give you an overview in terms of the Destination Zero goals that we are talking about. And if you really see the first goal, which talks about the facilities energy in terms of the greenhouse gas emissions reduction by 50% from the base level of 2018, at the year of 2030, we are looking for reducing the overall GHG emissions by 50%. With that in mind, the team started looking out in the opportunities, how quality function can really work towards in terms of contributing towards this Destination Zero goals. Definitely one of the areas that the team identified is where we test our engines post-production in our test cells. This consumes a lot of diesel because of the test cycles that are used to check the product in terms of the performance for the customers and for the customer specific requirements. The team really thought through in terms of how can we bring forward the overall GHG emissions by optimizing the test cycles. Is there an opportunity out over there, and can we really look forward to in terms of improving the quality without impacting or improving the GHG emissions reductions? So the team, a Six Sigma team was formed. Now Cummins has a very good culture of Six Sigma, and it is embedded in the culture of the organization. We have dedicated roles of master black belts, and there are people who also do projects as a part of the green belt. So a Six Sigma team was formed with the black belt taking a lead in terms of what can be done in terms of the test cycle optimization, because that was the major area that can be an opportunity when it comes down to the GHG emissions reduction. So base work was done in terms of checking what was the level of test cycles that were being used for the current products and the platforms out over there, and what are the opportunities also out over there in terms of the operations, that is of the auxiliary units that support the test cell entire system. All put together, can we have an opportunity to bring down the scope 1 and scope 2 GHG emissions without impacting the quality? And definitely energy management system was one of the key enablers that helped us in terms of really measuring, monitoring, and identifying the gaps in terms of what can be done differently in terms of the scope 2 generation and consumption of electricity as well. So with that project background, the team started really collecting data in terms of each of the platforms, what was the original test cycles and what can be the next level through the CAE analysis to check for in terms of whether the revised test cycles that the team was trying to contemplate to the simulation tests, when actually applied in the test cells during the testing cycles, would yield the same result or not, and would it be having no long-term impact when the engine is already in the field. With that premise in mind, the team started doing a lot of data mining in terms of collecting the data, in terms of the test cycles parameters, and in terms of collecting and trying to really project through the simulation analysis. A lot of tools were used like ANOVA and multivariate analysis. And overall results, although I'll come to it in the last slide, but overall results that started coming out that for all the 8 platforms that the team chose, the average time of testing came from 30 hours to 19 hours, which was a substantial reduction, I would say. bringing down a lot of savings in terms of the diesel as well as the reduction in the GHG or the greenhouse gas emissions. So that was the approach that we used. And since there was a lot of data that was already historically available with Cummins, we used all those of the data through the various tools of Six Sigma, and we were able to achieve the different levels of test cycles. The advantage that we had was that this is the first type of an innovation within the industry, which was never done by any of our competitors earlier, to the best of our knowledge. At the same time, we filed a patent because of the novelty of the project, and since it was a process innovation which was very dear to Cummins as an intellectual property right. And the biggest advantage that the team found was that this process can be scalable. Although they started with 8 platforms, but it can be scaled up to all 32 platforms that are there, which would be really amounting to huge savings in terms of the greenhouse gas emissions without impacting the quality for the customer. So a lot of tests were done. This is an example of a QSK23 model where the old test cycle was 63 minutes. The team did skip cycle tests and multiple assessments were done with respect to the skip cycle tests, as you get to see out over here. And then post that, the various KPIs that actually determine in terms of what is the performance of the engine when it comes out of the test cycle, that was not disturbed. So this is the old test cycles, and these were the parameters that we were talking about. So there were a lot of process changes that were done in terms of the old cycle and the new short cycle, and the comparisons were done with respect to the various critical indicators like lube oil temperature, coolant out temperature, the engine torque, engine speed in terms of the RPM. All of these were very closely monitored cycle after cycle to be oversure in terms of that the tests are not going to have any detrimental effect on the customer engine performance. And guess what? Both the results were in tandem to each other. In fact, some of the parameters, if you get to see in the new cycle, were actually showing better, which was further put up as a part of the innovation process. Because earlier we were never checking in terms of the sound, but when the new cycle was being tested, the team felt that we should also check the sound to be oversure that it does not really create any noise issue in the field going forward. So the cycle time got reduced for QSK23 to a new level of 37 minutes. And as I mentioned earlier, that we did not restrict ourselves in terms of only to the GHG emissions from the test cycles, but we also did a detailed analysis in terms of the energy management systems for the auxiliary units which support the test cells operating out over there with respect to the water temperatures, with respect to the electricity consumption, with respect to the dyno that is working, and all of this put together. So what we did is that we put up an EMS system which had a dashboard which was giving direct live feedback, and then the gaps were identified. Further to that, we also did certain on-site solar installations and changes in the area of the auxiliary units that supported further in terms of the overall scope 2 reductions. So what result did we have at the end of the product, at the end of the test cycles? We had a direct reduction from 8.81, which was the baseline at 2018, which is a normalized figure, to 3.44. Guess what? 2030 target was 4.41 as a 50% reduction of the baseline of 2018. But now we are already better than the 2030 target, and this is only with the 8 platforms that we are talking about. Going forward, when we apply it for all 32 platforms, that would really fetch us even better results. Additionally, what we did is that we installed something called a battery energy storage system, or the BESS, indigenously developed with one of our third-party suppliers. And the output of the dyno from the engine test cycle is getting stored in the BESS. This is further getting used into the system, and that is further helping us in terms of reducing the GHG emissions as a part of the scope 2, because that is getting utilized for the auxiliary unit power supply. So overall, if you see, there is a great achievement with respect to the 2030 goals that we were talking about. The output result speaks for itself. We never need not speak much on that. 37% test cycle time with a 48% diesel consumption reduction, 14% renewable energy, The quality performance has also improved because of the noise issue that we have addressed through the innovative approach. And now we are at a 96% on-time delivery. So the figure talks about itself, 80 crore till now from 3 months, and the annualized projection for all 32 platforms when implemented through would be somewhere around 300 plus crores, which would add to the bottom line of the organization. So that is what we have done, improved quality, at the same time address the sustainability issue. So that was the project, and I wanted to really thank you once again for giving us an opportunity to present our case. Thank you.